Next type of isomerism is your metamerism. We have already done chain isomerism, positional isomerism and functional isomerism. Alright. Now next is your metamerism. Now what is metamers? First we'll understand. Metamerism. Compounds having same molecular formula. Two or more compounds, they have the same molecular formula but different structural formula. Due to the attachment of different alkyl groups to the same functional groups are known as metamers. Again I repeat, when two or more compounds have the same molecular formula but different structural formula, due to the attachment of, listen carefully, due to the attachment of different alkyl groups to the same functional group. Alright, that means here the functional group will be in the middle and on the either side the alkyl groups will be attached is different, are known as metamers. Alright, again I repeat, the functional group will be in the middle, the functional group will be in the middle and the alkyl groups which is attached to the same functional group will be different. Alright, they are known as metamers and the phenomena is known as metamerism. So here those compounds will shows metamerism whose functional group lies in between the two alkyl groups. Alright, between the two alkyl groups whose functional group lies. For example, you can see ether. Like I am writing here CH3, CH2, CH2, CH3. What is this known as? Ethoxyethane. Isn't it? Ethoxyethane. Now I can write this one as in this way also CH3O, CH2, CH2, CH3. Can I write it? Yes. Now you see it here. What is that? It is nothing but methoxypropane. So what is that? The alkyl groups. Now first you count the carbon atoms and hydrogen, oxygen and see whether it is same or not. It should be same, na? It should be same. So how many carbon? Here that is 1, 2, 3, 4 carbons. 4 carbon. Hydrogen 3 to 5 to 7, 3, 10. 10. Oxygen, it is nothing but 1. Let us see here, same thing or not. 4 carbons, 5 plus 5, 10 hydrogen, correct, and 1 oxygen. Done. So these two compounds have got the same molecular formula, you can see, the structural formula is different. How it is different? Because the alkyl groups which is attached to it is different. You will say, sir, it is the same. You have to compare these two compounds, you don't have to compare this, you have to compound these two compounds. Understood? So hence it is being different, you can say that. Similarly, we can also write for secondary amines. Like suppose what we will do is that I will remove, let us say, NH. Alright, and instead of that, I will remove O and instead of that I will write NH. So what is this? It is nothing but it is a secondary amine. Secondary amine, this one is. So what is the name of this compound? The name of this compound is N-ethyl-ethanamine. N-ethyl-ethanamine. Ethanamine, what is the formula? C2H5, C2H5 NH2. So instead of one H, I have replaced one H by an alkyl group. Alright, so it is N-alkyl-alkanamine, so it is N-ethyl-ethanamine. Similarly, what we can say? It is N-methyl. N-methyl, so this is methyl, propanamine, because always root word means maximum number of carbon atoms. So it is propanamine, you can see that. Same thing, here the molecular formula is the same, C4H, how many? 3 to 5, 5 to 5, 5, 10 and 11. C4H11N, we can say that. That is C4H11N. So it is N-methyl propanamine in this way. So they show metamers. So they come under metamers. This is known as metamerism. In this way, instead of NH, you can also take sulfur. You can also take sulfur. Alright? It will form thioether. We can say that. Suppose here, if I use here sulfur, then it's what? That is ethyl thioether. Ethoxy I am saying, it will be ethyl, suppose sulfur here, S. Alright, ethyl thioether, we can say that. Clear? Ethyl thioether, the name will be. Okay, the name will vary here, the name will change. Ethyl thioether, understood? And here it is diethyl thioether, and here it is methyl propyl thioether. Methyl propyl thioether, we can say that. Okay, so in this way, the naming will be done for metamerism. Next, after that, we will come to the ring chain isomerism. What are ring chain isomers? Ring chain isomers means compounds having the same molecular formula but showing ring compounds also as well as the chain compounds also. That means compounds having the same molecular formula but the attachment of the carbon atom is different, due to which it can show ring as well as chain isomers are known as ring chain isomerism, we can say that. So what is the example we can give? The example is this, we can give it. See, here it is cyclobutane. This one is cyclobutane, we can say. And here also we can write it. The chain one is CH3, CH2, CH, CH2. What is that? Butene. Now you will say cyclobutane, sir, I am not able to count the carbon hydrogen. Okay, I will do it one thing. I will put the carbon hydrogen. Then you can count it easily. CH2, 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 CH2. How much it is? C4H8. Here also you count it. C4, 3 to 5, 1, 6 to 8. C4H8. Ring chain isomers. We can say that. Clear? In this way, we can have so many. We can have it. So many more compound we can have it. Like what you can do is that you can put here carbon, carbon, and here oxygen. You put it. Alright? It is oxygen. So here one carbon you put it. CH2, CH2, and CH2. Got it? Now you can write it in this way also. Got it? Clear? Now here it is CH3. I'll put a double bond here. Then CH. Then it is CH. Then OH. Now count it here. 3, 2, 5, 1, 6. And 6, 3 carbon and 1 oxygen. Here also same thing. 3 carbon, 6 hydrogen and 1 oxygen. You can count it. So this is known as what? Oxetane. This is said to be. It is nothing but, or you can also say that is 1, 2, 3 carbon atoms. You can also say 1, 3 epoxyethane. Sorry, ethane I am saying, propane. 1, 3 epoxy propane. See, first and third carbon atom epoxy, 1, 3 epoxy propane, or you can say oxetane. And this one is nothing but prop, 1 in, 1 all. Or you can put the double bond here also, you can put it. You can put the double bond here also. Got it? And you can write it here. Prop 2 in 1 all. Either you can write prop 1 in 1 all, or you can write prop 2 in 1 all. So whatever it is, these two compounds having the same molecular formula, but they show ring as well as a chain compound. So it is known as what? Ring chain isomerism. Got it? So in this way, that is, we learned about metamerism, we learned about ring chain isomerism. Thank you very much.